Hello, 7th graders. Your next video is for section 4.7, which is on proportional relationships. So we're just going to continue on with our dealing with the proportional thinking. Remember that proportional really just means equal. And so we're going to talk about the constant of proportionality, which is the value of the ratio of quantities in a proportional relationship. What does that really mean? It just means your ratios. Like when we looked at the two different figures that were supposed to be similar, and we had to have a proportional ratio between the two figures, it's the same thing. Okay, so to be considered proportional, remember that the ratios of the two quantities has to be equal to each other. So here's an example. It says the table shows the distance Dave rode in a bike-a-thon. Is there a proportional relationship? And then explain it. Okay, so you have his hours and you have his miles. Okay, so at hour 0, he drove 0 miles. Well, that's kind of obvious. At 3 miles, he drove 18.6. 6 miles, 35.2. 8 miles, 49.6. 9 miles, 56.8. What they're asking you is, are the ratios equivalent the whole way across? So the whole thing has to work, and if it doesn't, then it's not. Okay, so if you look at this, like how much is it changing from here to here? 3, 3, 2, 1. And then if you're looking at here, it's changing 18.6, 16.6, 14.4, 7.2. Is it changing at the same rate the whole way? Like here it started out going 3 hours at a time, which would have been fine, but then it went 2 and then it went 1. Then you have to look at the changes, right? So are the ratios equivalent? The 1 over 7.2 is equivalent. The 2 over 14.4 would be equivalent to this. But 3 over this and 3 over this, those would not be equivalent. So the answer is no. Ratios aren't equal. That's how you would explain it. The ratios are not equal. Doesn't. So here's a different type of problem, but you're still dealing with the same concept, which is proportional thinking, the constant of proportionality. So this one says, use the graph below to see what Damon's reading speed is in pages per day. So in other words, they want you to break it down, right, to a unit rate. So I'm only giving you two things here. I'm giving you, this is time and this is pages, okay? So this is saying that in 2 days, he's reading 40 pages, and in 4 days, he's reading 80 pages. Okay, so I need to break it down. Well, if I have 2 to 40 and 4 to 80, those both reduce to the same thing, which is 1 to 20. So what is that saying? That's saying that Damon reads 20 pages per day. So the constant of proportionality would be that. It has to be the same for both, right? Otherwise, they wouldn't both be on that line. My last example is another table, and you're going to have to find the constant of proportionality for this table. So if it takes me this many yards of fabric to make this many blankets, again, you're just going to look at the ratios. So if it takes 16 yards for 8 blankets, 32 yards for 16 blankets, 40 yards for 20 blankets. Again, for it to be proportional, they all have to be the same all the way across, right? They're not asking if it's proportional. They want you to find the actual constant, okay, that they're using, the ratio that they're using. So if you break these down, if you reduce them, you'd get 2 to 1, 2 to 1, 2 to 1, right? So then your ratio is 2 to 1. You could also say 2 yards per blanket, because that's what that really means, right? 2 yards of fabric per blanket made. Okay, so there's a couple different ways, again, to apply what we've learned about proportional thinking. So bring that knowledge with you, and we will talk about it more tomorrow. Have a good night.